We start by listing what we already know. For this particular problem, we know that Q1 is equal to 5 millicoulombs. We also know that Q2 is equal to 9 millicoulombs. And we know that force is equal to 4.05 times 10 to the third. And we already know that K is equal to 9 times 10 to the 9 Newton meter squared over Coulomb squared. Now, in order to find the new force between the spheres, we have to know what R is. So basically, first we're going to solve for R before we start solving for a new force. So force is equal to K, Q1, Q2 over R squared. So isolating the variable R from that equation, we get that R is equal to K, Q1, Q2 over F and the square root of this entire formula. So, plugging in our numbers, we get that R is equal to 9 times 10 to the 9 times 5 times 10 to the negative 3, because it is millicoulombs, times 9 times 10 to the negative 3, because that is also millicoulombs, over 4.05 times 10 to the third, and the square root of this entire thing. So you get that R is equal to 10 meters. So now that we know R, we can look for the force after the two spheres have been touched. Since the two spheres have been touched, we can say that Q1 is equal to Q2 is equal to Q total over 2. In order to find Q total, we do 5 plus negative 9, so we get that Q total equals negative 4 millicoulombs divided by 2. So it equals negative 2 millicoulombs. Now we use the original equation. Force equals K Q1 Q2 over R squared. However, since Q1 is equal to Q2, we can say that force is equal to K Q squared over R squared. So we get that 9 times 10 to the 9 times 2 times 10 to the negative 3, since it is 2 millicoulombs, over 10 squared, since that is a radius we got from above. So we get that force is equal to 360 newtons. And since in order to find the force attractive or repulsive, we are given that we have a negative charge and another negative, so they're going to try to go away from each other. So the force is 360 newtons repulsive.